Well, in the previous video, I've introduced the topic of the anatomic chains or functional anatomic chains, which could be considered as, let's say, complex units built upon the connectivity of individual muscle units or different muscles groups. The key point to consider, to be, let's say, remembered here is the anatomical linkage between different muscles, let's say, belonging to the same anatomic chain. So from an anatomical perspective, the structure which is connecting, let's say, two or more muscles of the same chain is the so-called fascia. So the fascia, from a morphological point of view, it's a sort of connective tissue that runs along the superficial layer of, let's say, consecutive muscles and connects them from an anatomical, sensitive and sensorial perspective, but also has an influence on the mechanical responses of muscles acting by interplaying with each other. So based on these, let's say, body configuration and morphological characteristics, we can identify or classify the anatomic chains based on two main features. The chains could be defined based on the, let's say, on the specific place where they are placed, and therefore we have front, back or lateral chains. For the upper body we have dedicated chains, 4 chains, which are classified once again based upon their specific position. In fact, we can have chains based on the layer where they are distributed in the body. So we can identify superficial and deep chains, and their specific position is going to influence also the functionality and demands they have in terms of stability and mobility. So from a postural perspective, from a movement perspective. So let's consider each one of these chains. I will provide you, let's say, I will give a very brief overview of each individual chain and what are the main functions from a postural or from a movement perspective. So the first one is the superficial back chain. So as you can easily understand, the superficial back chain is the one running, let's say, that connects the entire posterior surface of the body from the bottom of the foot to the top of the head, and mostly in 2 pieces. So we can, let's say, consider the superficial back chain as made up by 2 halves: the one from the toes to the knees and the one from the knees to the brow, so from to the skull. The superficial back chain has different functions. So from a postural perspective, the main aim of or the main role of this anatomic chain is to support the body in a full upright position, a full upright extension, and obviously to let's say, to mitigate the tendency to curl over into a flexion, as in a flexion pattern as that exemplified by the fetal position. So actually a very early stage of life. When let's say, considering the movement function of this chain, so obviously it's natural to consider that this chain placed on the back of the body and connecting the top of the head with the bottom of the feet probably has a role, a major role in facilitating the extension movement of the body from the very early stage of life, when actually a child not already able to let's say to walk, actually strolling, and progressively he or she gain let's say the skills and the capabilities to stand upright, and obviously to start walking, and eventually to perform extension based movement patterns. So in these cases, obviously the superficial back chain has a very specific role. Well, the second anatomic chain is the sort of antagonist of the previous one. So now I'm referring to the superficial front line. This anatomic chain actually connects the entire anterior surface of the body from the top of the feet to the side of the skull in two pieces, again from the toes to the pelvis, and from the pelvis to the head. From a postural perspective, the function or the functionality, the role of the superficial front line actually is to balance literally the action of the superficial back line, and to provide a sort of tensile support, let's say from the top, to lift those parts of the human body that counteract the extension made by the back chain. Again, as for the superficial back chain, we can identify two different halves. The one facilitating mostly flexion patterns of the lower limbs. So the half running from the top of the feet to the pelvis could facilitate movements like hip flexion together with knee extension and foot or ankle dorsiflexion, while the upper body is facilitating let's say a curl or a flexion pattern of the trunk across the pelvis. So just to let's say to sum up together the roles of these two initial anatomic chains. In general, the superficial back chain and the superficial front chain have the role to maintain primarily the sagittal postural balance, so the anterior posterior balance, by let's say counteracting each other with antagonism and with antagonist forces from the from the front to the back of the body. Okay, now is the turn of the lateral line. So for the lateral line, actually we are talking about two lines, because there are two symmetric lines on each side of the body. From an anatomical perspective, the lateral line actually brackets each side of the body from the medial and lateral midpoint of the foot, and it climbs up around the outside of the ankle to the lateral aspect of the leg and the thigh, and obviously passes along the trunk and reaches the area under the shoulder, and it attaches to the skull in the region of the ear. From a postural perspective, the lateral lines actually counteracts each other, and as a main role they have that to posturally balance sideway dysfunctional patterns, so to keep the body in an upright position, and together with all the other lines to create a sort of corset, a muscular corset around the trunk. from a movement perspective, the lateral line participates in creating a lateral bend of the body, so lateral flexion of the trunk, participates in the abduction of the hip, one of the most common examples of, let's say, movement tasks requiring the involvement and the contribution of the lateral chain are shuffles, so side steps, but from let's say a stabilization perspective, these chains are very important or heavily, massively involved in breaking lateral and rotational movements of the trunk. Just consider change of direction tasks when the foot is planted onto the ground and the lateral chain has to, let's say, avoid unfunctional movement patterns or, let's say, exaggerated forces which could have, let's say, detrimental effects on the soft body structures and tissues. Okay, next line is the spiral line. So actually the spiral line loops around the body like as two opposing helices, right and left, and this chain begins to attach, let's say, at the top end at the skull, and goes down across the upper back of the opposite shoulder, and then again around the ribs to the front, and down to the hip. Now from the hip, the spiral line passes like a jump rope along the anterolateral thigh, and then reaches the foot on the front plane, while in the back plane there is a part of this chain that is reaching through the leg, the ischium and the rector spinae myofascia. So actually this chain from a postural perspective has the role to wrap the body in a double spiral in order to maintain the balance across all the planes. And from let's say neuromuscular and mechanical perspective, this chain is able to counteract through different muscular contraction modalities, isometric, eccentric, concentric, let's say disruptive forces acting at very far points of the body. So from again from a postural perspective, the role of the spiral chain is that to absorb, is that to limit, is that to balance forces acting on different parts of the body, trying to limit the let's say the harmful effects of these forces. From a movement perspective, the movement function of the spiral line is to, let's say, to create, mediate oblique and rotational movement patterns, again through a combination of eccentric, isometric contractions. Just to give an example, a ball throw with a rotational pattern, or a wood chop exercise where the lower body is stabilized and across the pelvis we have an isometric contraction facilitating the rotational movement of the upper body, is again massively requiring the contribution of the spiral line. Well, the next lines are the two functional lines. So the functional lines extend the arm lines, which will be, let's say, described later. So these lines do extend from the surface of the trunk to the contralateral pelvis and the leg segment. So actually what they do, they run across the body and across the back, and then they create lines together, forming a sort of X across the torso. So we have literally, anatomically, a front functional line and a back functional line. From a postural perspective, so these lines have the role to support the most common tasks of the daily life, so walking, running, climbing stairs, because of the cross pattern that this kind of tasks required to do. So a movement of upper arm and contralateral lower limb. Again, these two functional lines are acting as a support of the upper limbs chains and the lower limbs ones, so to facilitate the smoothness of the movements and to keep motor control across the trunk and the pelvis. And we will see later how these chains, the functional ones, actually are connected to the deep chains that have a more specific postural related or stabilization related role. In details, the back functional line begins with let's say at the attachment of the latissimus dorsi muscles, and it runs down and crossing the body, the center of the body. Actually it goes to join the sacrolumbar fascia. So this back functional line crosses the midline, so to provide stabilization of the lower back and facilitating the movements across, let's say, the center of the body, like javelin throws or overhead actions like spiking actions, throws, or like the actions commonly performed by volleyball players and pitchers. With regard to the front functional line, this anatomic chain begins, let's say, at about the same place of the back one, at the distal attachment of the, let's say, antagonist muscle of the latissimus dorsi, which is the pectoralis major, and it moves across the trunk, wrapping the fifth and sixth ribs, and finally it goes down and attach at the anterior surface of the anterior superior iliac spine, and finally ends up at the inner side of the femur. As mentioned before, this functional line has a role both as a stabilizer and a mobilizer, especially for the rotational movements. Well, another big, very important line laying in the very inner side of the human body is the deep front line. So the deep front line is anatomically interposed between the left and the right lateral lines in the, let's say, in the frontal plane, and it's like sandwiched between the superficial front and the superficial back line, and it has also functional connectivity with the two functional lines previously described. Let's say, due to its specific position, makes sense that the deep anatomic chain, or the deep anatomic line, has a specific role in stabilization. In fact, among the main functions from a postural perspective, this chain facilitates the lifting of the inner arc, so where actually the lungs are placed. It helps stabilizing each segment of the legs, so hip and thigh and shin support the lumbar spine from the front, so providing a sort of support, functional support when the lumbar spine extends, and avoid dysfunctional range of motions. Also support and shape the abdominal and pelvic balloon, so have a very important role in preserving, let's say, some of the organs which are placed in the abdominal and pelvic cavity. Stabilize the chest and facilitates the expansion and the relaxations of the breathing, and finally has a role in stabilizing the neck and the head atop it all. From a movement, let's say, perspective, as I said earlier, this chain has marginal roles, but probably it serves as a sort of absorber when exaggerated movements performed by the more superficial anatomic chains are done. So the role of the deep chain is to accompany the action of the more superficial ones, trying to avoid dysfunctional, detrimental forces and moments acting on the body. So moving to the next slide, we have here the arm lines. So the arm lines are, let's say, treated separately because they are very specifically let's say, dedicated to the stabilization and mobilization of the upper limbs. They are commonly classified as a superficial and deep, depending on the specific layers they are placed. From let's say a postural perspective, the deep ones are those involved in stabilizing the joints of the upper limbs, mostly the shoulder joint. In fact, this line is the one creating the so-called rotator, or including the so-called rotator cuff, so a combination of muscles, tendons, fascia and connective tissues, creating, let's say, accommodating the socket of the scapular bone for, let's say, connecting the head of the humerus. While the superficial lines have mostly movement or mobility rules, they are placed, let's say, at let's say the most superficial layer of the body, and they are involved on let's say during the most common flexion, extension, internal and external rotational movements of the upper limbs. Well, during the previous slides, you have probably heard me saying many times or mentioning two of the most important concepts in human movement and in movement evaluation. So I mentioned many times stabilization and mobilization. So these are, in general, overall, the two main aim the human body try, or at least seek to accomplish when executing a specific motor or movement task. First of all, in order to let's say better understand how these two main and relevant roles can be accomplished, we should consider how the different functional lines, the one already mentioned, work together and contribute to achieve the specific goal. So essentially, the anatomic chains, or in general, every single muscle is required to either absorb forces or to produce forces. So I can give you two very basic and simple examples about what I just mentioned. So in terms of force absorption or mechanical force absorption, we can consider a common task like let's say descending the stairs or stepping down from the top of a box, where actually all the muscles of the lower limb, beginning with the ankle plantar flexion, and then with the knee extensors, and finally with the hip extensors. So these muscles are acting eccentrically, trying to let's say to absorb the forces required to perform that task. So in that case, we are considering the muscles as absorbers units. So they are demanding to absorb forces. They are demanding to eventually limit the harmfulness effects of those forces. This is very relevant, for example, during landing from a certain height, when following a heading situation or following a jump finalized to spike a ball in volleyball. On the other side, the same muscles could also act, contribute, and facilitate tasks where the main aim is to produce energy, so to generate forces. And in this case, so the muscles, rather than absorber, act as force generators. So they are strengthening, they are shortening very quick, with a very high or fast rate of force development. They are transferring these forces from one to each other in order to have a cumulative effect finalized to complete the task. So in general, whatever the task demanded is gonna be, a potential let's say lack of continuity or problems in the interplay between muscles of the same chain or chain acting as let's say contributors to the same task may cause some problems. And the problems could be, let's say, from the energy absorption perspective, a malalignment, and then forces acting on specific structures, units, and soft tissues, which on long term, when these repetitive forces are continuously acting, can create morphological changes and can eventually lead to injuries. On the other side, a deficit of forces, let's say a deficit in the transmission of forces from the lower limb through the pelvis to the trunk up to the upper limb, as for a tennis serve, could bring to a non-functional performance or to a reduced performance, which is not let's say fully utilizing the potential of the body. So in this case, we define this specific situation a weak or a dysfunctional performance, both for the energy absorption tasks and for the energy production ones. So this actually lead me to the next slide, where depending on the specific role and the specific of the anatomic chains and the specific or general overall task aims or task objectives, we can clearly classify tasks according to two main categories. We have a task mostly finalized to achieve, to pursue functional stability, where for functional stability we do define the ability of the body to have a full, a complete, an overall control around the lumbar spine and the single joint, in order to facilitate the movement itself. While for mobility, we do consider the ability of the body to transfer forces with, let's say, an optimum carry-on to control those forces from the, let's say, initiator, or where actually the onset of the forces occurred, toward the end of the anatomic chain. So there is a continuity between muscles of the same anatomic chains and anatomic chains acting in parallel in order to facilitate and in order to optimize the movement itself. Well, when considering these two main aims of a movement, and from a movement assessment perspective, we can create a sort of workflow finalized to characterize each one of the two main tasks with, let's say, key phases, key events, trying to identify for each one of them the main anatomic trains involved, or where the anatomic chains are contributing the most, and the specific characteristics for each one of them. So if we consider the stability, so for the stability, we do know that some anatomic chains, mostly those placed at the, let's say, inner layers of the body, do contribute the most for facilitating both static and dynamic stability. So in this case, we will describe the role of these anatomic chains as finalized to provide either or both static and dynamic balance. We can characterize, or we can classify the base of support, which could be either single or double leg support, could be parallel depending on the specific feet position, or could be a split support. And finally, we are gonna look at the full body alignment by considering lines which run across the body and allow us to identify eventual misfunctional patterns. From a mobility perspective, obviously we will be looking at the same anatomic trains, but probably those placed on the outer layers of the body, the more superficial ones, which are, let's say, more demanded to perform movement and to, let's say, produce energy and making the body move for a specific movement task. So in this case, our focus will be more attracted by the force production, so the ability of the trains to contribute to produce forces, and the specific characteristics of force production. So we'll be looking at the rate of force production when a task is performed at a very high rate of force production. So it's commonly defined as explosive tasks, so jumps, sprints, eating movements, spikes in volleyball, kicks, shoots, these kind of actions, or actions actually requiring a less demanding or less quick or a relatively lower rate of force development, like walking, like jogging, like rowing in some cases, like cycling for non-competitive objectives. And finally, we'll be looking at the force transfer, so how the different muscles interconnected each other in the same anatomic train are able to work with an ideal optimum timing, so one after the one after the other, with a very short coupling time in order to optimize the transfer and the carry on of the forces. And finally, the force orientation. Force orientation is a very important topic when we consider the mechanical profile of the movement tasks that have to be performed. I give you two examples. So when we want to jump, like in a block jump in volleyball, probably from a mechanical perspective, the key components will be the vertical forces we are able to produce against onto the ground in order to jump as high as possible, which is very different from an horizontal oriented task like sprinting or accelerating, where probably we're gonna produce the same amount of forces, but these forces will be more horizontal rather than vertical. So the vector of forces is shifting from a vertical plane toward an horizontal plane. Well, this was the last slide of this presentation. In the next video, I'm gonna show you how a common athletic task can be broken down into main phases, how we can analyze the main phases by considering the anatomic chains, the main goals, stability against mobility, and the specific and key characteristics for each one of them. Thank you for your attention, and again, you are more than welcome to post questions on our virtual learning environment on Moodle, so to facilitate the learning and the interaction between you as teammates or classmates and me as and Colin as teaching staff. Thank you.